The greatest mystery in science isn't a question of where to dig, it's a problem of signal processing. Current mission architectures focus on delivering 1,000 humans to the red planet within decades, assuming we can simply walk up and find life. But human latency is fatal for discovery because by the time Earth sends instructions, the optimal window has passed. The engineering reality is that autonomous machines must bridge the gap between arriving and finding. We aren't waiting for humans to be the first contact. We are building swarms capable of subsurface sensing before a human boot ever touches Martian soil. The search for life on Mars is often framed as an excavation challenge, but it is fundamentally a signal processing problem. We are looking for faint biological signatures buried beneath layers of radiation and regolith. To find them, we cannot rely on the slow, manual driving that limits our reach when the signal is faint. The fundamental constraint in this race isn't propulsion or life support. It is communication latency. A round-trip message to Mars takes roughly 20 minutes one way. In an era where a rover might spend hours waiting for a command from Earth just to move forward, we are effectively blind to transient opportunities. For years, the standard operating procedure was defined by this delay. The Curiosity rover operated with only 6% autonomy in its driving capabilities. This meant that after every movement, engineers on Earth had to analyze camera data, plan the next path, and send commands back up the line. It was a logistical marathon where the robot moved at the speed of human decision-making across an ocean of space. By the time the rover arrived at a promising rock formation, the lighting might have changed, or dust storms could have shifted the environment entirely. The window for discovery had closed before the command even left Earth's atmosphere. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The paradigm shift began with Perseverance, which achieved roughly 90% autonomous driving capability by early 2026. This isn't just a software update. It is a fundamental re-engineering of how robots perceive and interact with their environment in real time. These machines can now traverse boulder-strewn terrain without waiting for ground control to validate every step. They make decisions about where to go based on immediate sensory input, effectively turning the exploration into a continuous operation rather than a series of paused and resume cycles dictated by light-speed physics. This leap from human-guided pacing to real-time discovery is what allows us to cover more ground and find those faint signals before they are lost to time or changing conditions. However, speed alone isn't enough if the robot destroys the evidence it seeks. For decades, robotic arms were designed with rigid collision avoidance protocols that treated every object as a hazard to be avoided at all costs. This safety-first approach was necessary for industrial settings, but is counterproductive when searching for delicate biosignatures. The solution lies in what researchers call contact anticipation. Advanced manipulators now utilize onboard proximity sensors and dynamic thresholding algorithms that allow them to handle potential samples with the delicacy of a human hand rather than the forceps of a machine. Instead of simply moving away from an object, these systems can actively anticipate physical contact, adjusting their grip in milliseconds based on feedback loops that detect subtle changes in resistance or texture. This moves us beyond passive safety into active intelligence. We are building machines that understand they might be holding something alive and adjust their force accordingly to avoid crushing a potential fossil while collecting the data needed to confirm it. Without this capability, we risk destroying the very evidence we travel across the solar system to find, turning our most advanced tools into blunt instruments in a museum of discovery. The physical constraints of Mars make this autonomy even more critical and difficult than on Earth or the Moon. We have already seen proof that small-scale autonomous scouts can operate independently in these hostile conditions through the Ingenuity helicopter. It weighs only 1.8 kilograms with a rotor span of just over 1 meter, yet it operates successfully in an atmosphere less than 1% as dense as our own. This feat proves that powered flight and autonomous navigation are viable without real-time human intervention from Earth. Ingenuity validates the shift from ground-based scanning to aerial autonomy, mapping terrain and identifying high-value targets for subsurface analysis faster than any surface rover could alone. If you think the next step is sending astronauts to walk on rocks, you are missing the actual bottleneck. The human element is a logistical constraint that slows down discovery by orders of magnitude while we wait for instructions to cross millions of miles. While academic proposals outline architectures for permanent settlements relying on repeated cargo launches and thousands of crew members, these plans treat exploration as a continuous parallel activity rather than a prerequisite. They do not address the specific engineering need for pre-deployed autonomous swarms capable of subsurface sensing before human arrival. The race for life isn't about who gets there first with boots. It is about which autonomous system can process sensory data fast enough to find a signal before Earth-based instructions arrive too late. We are moving from an era where robots follow human commands to one where machines decide what to investigate, turning Mars exploration into a real-time intelligence operation rather than a slow-motion excavation. The future of finding life on the Red Planet depends not on how many humans we can land, but on how intelligent our first steps were before those humans ever arrived. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.